So today we are going to be doing the questions on Euclidean geometry from the question paper from the Department of Education, November 2024, November 2024. That is, we are going to start with question 9. So it is very important to read the information that is provided. Then compare with the diagram. In this case, you are given, in the diagram, A, B, C, D is a cyclic quad. BC is produced to E. AC is drawn. Then you are told that A1 is equal to half of B. Then A2 is equal to 46 degrees. Then C1 is equal to 86 degrees. So in this case, the first part is saying calculate with a reason the value of A1. Calculate with a reason the value of A1. If we are to check, we are having a cyclic quad. And we have an exterior angle because this side has been produced. So from the exterior angle theorems of a cyclic quad, we can therefore conclude that the angle, this C1, is equal to the entire angle DAB. So in other words, what are we saying? Question 9.1. We are saying the angle C1 is equal to that whole angle, which is A1 plus A2. The reason for that is exterior angle of a cyclic quad. Exterior angle of cyclic quad. Then from there, C1 is provided to be 86 degrees, which is equal to A1. We don't know A1. It's the requirement of the question to calculate A1 plus A2. A2, we are given it to be 46 degrees. So plus 46 degrees. Then transpose the 46 to the other side. So we are saying 86 degrees minus 46 degrees must be equal to our A1. Therefore, our A1 will be equal to 86 minus 46. We are going to get it will be equal to 40 degrees is equal to A1. Question 9.2, what are we required to prove? They are saying, hence prove that AD is equal to DC. They are saying AD is equal to DC. If we are to prove that AD is equal to DC, one way of proving that is to concentrate on triangle ADC. Is to concentrate on this triangle. If we are to concentrate on that particular triangle, means we have to prove that this angle is equal to this angle. Then we can conclude that this side is equal to this side. Those will be sides opposite equal angles. Then it means from there we can now go. It means we have this angle, we found this angle to be 40 degrees. So in other words, what this question is wanting you to prove is to prove that this angle C2 is 40 degrees. But since we do not know this angle, it means we can't go there straight. But there's information that we are provided in the question. We are provided that A1 is equal to, we are provided that A1 is equal to half B. But A1, we found it already. This A1, we found it to be 40 degrees. So it means 40 degrees, that is equal to half of angle B. Then multiplying both sides by 2, it would therefore means 40 degrees times 2 must be equal to our angle B. Therefore, we can conclude that 80 degrees is equal to our angle B. We now know this angle. We now know this angle is 80 degrees. We now know this angle is 80 degrees. But if we were, from the given information, we are told that A, B, C, D is cyclic quad, and we know that the opposite angles of a cyclic quad supplement. So it means, from here, it means we can now say angle D plus angle B must be equal to 180 degrees. Why are we saying so? These are opposite interior angles of a cyclic quad. Opposite interior angles of cyclic quad. These are opposite interior angles of cyclic quad. Then what's the angle D? We don't know. We want to calculate it. So let's put it. So your D plus, what's the angle B? B, we found it to be 80 degrees. That must be equal to 180 degrees. Therefore, our angle D is equal to 180 degrees minus 80 degrees after transposing the 80 degrees, which is going to give us 100 degrees. Now go back to the triangle which we covered in green. We now have this angle which we just calculated to be 100 degrees. We now want to calculate the third angle. If you check from there, that's right here, we know that the angle D plus the angle A1 plus the angle C2 must give us 180 degrees. That must give us 180 degrees. What are the reasons for that? These are sum of angles in a triangle. Those are sum of angles in a triangle. What's the size of D? We just obtained that is 100 degrees. Plus, what's the size of A? We don't know the size of A. What's the size of C? Sorry, the size of A, we have it. The size of A1 is 40 degrees. Plus the size of C2, which we do not know. That must give us 180 degrees. Then leaving C2 alone, so it means C2 is equal to 180 degrees minus, when you transpose the 100 there, 100 degrees minus the transposing of the 40 there, which is going to give us an answer of 40 degrees, which we said initially that we have to prove that this angle C2 is equal to that angle 1. So as we can see, we have just proven that C2 is equal to angle A1. Why are we saying so? Both equal to 40 degrees. Then from there, we can therefore conclude that hence AD is equal to DC. What is the reason for that? These are sides opposite equal angles. Or alternatively, the reason you can write it as converse of angles opposite equal sides. Here on this question 9.2, it is noted, it is also important to note that, as they say in Euclidean, there is no royal way to Euclidean geometry. It was important to note that after someone had calculated that B is equal to 80 degrees, instead of using the cyclic quad, from here, from this step here, someone would just come and calculate the angle C3. So it means someone was going to come and say, therefore, C3 plus B plus A2 must be equal to 180 degrees. What was the reason for that? Then the reason they are going to say sum of angles in a triangle, because we are concentrating in triangle ABC. These are sum of angles in a triangle. Therefore, we are going to say C3 will be equal to, plus our B, which we found to be 80 degrees, plus our A2, which was given as 46 degrees, will be equal to 180 degrees. Solving for our C3, it therefore means our C3 was gonna be equal to 180 degrees minus 80 degrees minus 46 degrees. Then the answer was gonna be 54 degrees. When we get 54 degrees, it means this part is 54 degrees. Then this one, ECB, we are given it's a straight line. We are given that is a straight line. So we can now conclude that angle C1 plus angle C2 plus angle C3 must be equal to 180 degrees. What is the reason for that? These are angles on a straight line. Angles on a straight line. Therefore, our C1, we know it's 86 degrees, it's given, plus our C2, which we do not know, plus our C3, which we calculated to be 54 degrees. Here it is equal to 180 degrees. Then we can say, therefore, our C2 is equal to 180 degrees minus 86 degrees minus 54 degrees, which is going to give us 40 degrees. Once you get the 40 degrees, we are going to just do, therefore, our C2, if you check, it's 40 degrees, is equal to our A1, which was calculated in our 9.1 there. Both are equal to 40 degrees. Hence, AD is equal to DC. Those are sides opposite equal angles, or the converse of angles opposite equal sides. Then we are on question 10.1. In this question, we are given in the diagram, we are having triangle RST is drawn, and you are told that a line AB is drawn bisecting RS and RT at A and B respectively, such that AB is parallel to ST is provided there. Then prove the theorem which states that the line parallel to one side of a triangle divides the other two sides proportionately. In other words, they are saying prove that RA, which is from here to here, RA over AS, this part, will be equal to RB, which is this part, over BT, which is this part. So for you to be able to do that proof, the first step is you have to construct diagonals in the quadrilateral ABTS. So we have to construct diagonals. You have to construct diagonals as your first step. Then so the first step, as we agreed, said we have to draw the diagonals. So, and what you do, you have to write it. So we are going to say construct diagonals construct diagonals AB, sorry, it's AT, and the other diagonal is BS. So from what we already have, we have to know that area of triangle, RAB is equal to area of triangle is equal to area of triangle RBA. What's the reason for that? It's same triangle or common triangle. It's same triangle. Then we can also conclude that area of triangle AST is equal to area of triangle RBS. Sorry, BTS. Area of triangle BTS. What's the reason for that? If you check here, they are sharing the same base and they have a common height. They have a common perpendicular height. So the reason is equal base, equal height. if you check, they are sharing the same base ST. So when we say equal base, we can just write it as same base. Then the height is the distance between these two parallel lines. That's our reason. So once we have that, we can therefore conclude that area of triangle RAB over area of triangle then it's area of triangle RAST must be equal to area of triangle RBA divided by area of triangle R area of triangle BTS. The triangles that we wrote there on top there. Then from there, we use the formula for calculating the area. But take note when taking the area for calculating the area, we link the size that we want. We don't just take any size. So in this case, we know the area for calculating the triangle using the area rule is half. Then RA half times RA, we are using area rule times AB times sine of the angle, included angle. So it's sine RAB divided by half. Here we are talking of this triangle, so it's gonna be AS times ST then sine the included angle, which is AST. This must be equal to area of triangle RBA. So we are going to say half. The side will take RB times BA then the included angle. The included angle is gonna be equal to RBA sine RBA divided by half. Then the sides will take this BT then we take TS sine of the included angle, which is BTS, but in this case, we are supposed to take note that this angle RAB here, let me put it here. We are saying, but the angle RAB, this angle RAB is equal to the angle AST, is equal to the angle AST. What is the reason for that? You are given that this side and this side are parallel. So these two angles are equal. They correspond to each other. The reason we have corresponding angles, which sides are parallel, we are given that AB is parallel to ST. And again, the angle RBA, the angle RBA here, RBA will be equal to the angle BTS. The reason, if we check, we are saying this angle and this angle are equal. They are corresponding angles. They are corresponding angles. So this becomes, these are corresponding angles. And the reason is the same pair of parallel lines. Therefore, it means this sine, since this angle and this angle are proven to be equal, it means this one and this one will give us 1. This one and this one will cancel out. So we'll be left with RA times AB all over AS times ST will be equal to R this and this will go out, so we'll be left with RB times BA which is being equal to that one. But we proved that RBA, that angle, is equal to angle BTS. Therefore, these again will cancel out. So you'll be left on the denominator with BT multiplied by TS. Then from here, you need to revisit your algebra so that you come to this ratio. If you check in this particular case, we have to check in this particular case, we can just take this, we can just cross multiply. This one comes here, this one comes there. In other words, we are saying we multiply both sides by ST. We multiply here by ST. Then we divide both sides by BA. We divide both sides by BA. Then if we are to check, this ST and this ST will cancel out. this AB is the same as the BA. We are left with RA over AS being equal to, here it's gonna be RB, because the BA here will cancel with the BA here. Here the TS is the same as the ST. They cancel here, is equal to RB over BT. It's proven. And as we can see, as illustrated earlier, or as said earlier, there is no royal way to Euclidean. We can do it in a different way, but it's still going to the same results. If we check in this case, if we are to check in this case, we, instead of using, on our numerator, you use the same triangles. So we can say triangle, we can take the same triangles there. Then we say area of triangle RAB is equal to area of triangle RBA. The reasons that we are going to provide is the same triangle is provided there. Then the next, instead of taking this triangle AST, the ones that we took there, you can take the triangle ASB. So we can say area is the second one, area of triangle ASB. ASB is equal to area of triangle area of triangle the other one, the first one we took ASB, the second one we are going to took BT, A triangle BTA. If you check, we are talking of triangle ASB and triangle BTA. If you check, they have a common base and they have the same height. So the reason that we are going to use is because they have a common base and their heights are equal heights. Why are we saying they are equal? Because they are between two different between two parallel lines. Then from there, we can now say the area of triangle RAB. From there, we can therefore say the area of triangle RAB, this one, the area of triangle RAB over the area of triangle ASB must be equal to area of triangle. We go here, triangle RBA divided by area of triangle. Yes, triangle. Area of triangle BTA. In other words, we said this area divided by this area must be equal to this area divided by this area. Then from there, how do we get the area of a triangle? It's half. Base, we are going to talk of the side that we want, which is RA. Then the other side is R. The other side is AB. Then we are going to have sine of RAB. Divided by half. Then here we are going to have AS. Then we consider the side AB. Then the angle that we'll be talking about will be BAS. BAS or SAB. Which is equal to half area. Then the side is RB. Then we have BA. Then the included angle is gonna be sine RBA divided by RBA is the included angle here is your RBA, then divided by half BT, then we have BA sine. The included angle, if you check in this particular case, the included angle is TBA. So the AB and the AB will cancel out the half, and the half will cancel out. We are left with RA over AS. There we are having sine RAB. But in this case, this is our RAB, this angle. But the other angle which is on our denominator, it's SAB. It's SAB. If you check, this is a straight line. This is a straight line. So it means this angle is going to be equal to 180 degrees minus the RAB. So here it means it's going to be sine 180 degrees minus RAB. In other words, we are supposed to know that RAB plus SAB is equal to 180 degrees. The reason angles on a straight line, on a straight line. Then from there, it would therefore means the SAB, the angle SAB is equal to 180 degrees minus angle RAB. This is what we got here. Then we go to the other side. We said that and that it cancelled. This and this have gone. The same will happen to the left. This and that will cancel. So we are left with the AB will cancel. We are left with RB multiplied by sine RBA all over BT times sine. If we check again, we have this angle RBA. Here is our angle RBA. This one. Then the other angle is in this triangle, which we said is TBA. But if you check, these two angles make a straight line, meaning to say this becomes angle TBA is 180 degrees minus angle RBA. So here it simply means we are saying RBA plus the angle TBA is giving us 180. The reason these are angles on a straight line. So we can conclude that the angle TBA is equal to 180 degrees minus the angle RBA Therefore, from our reduction, we know that sine from our reduction, we know that sine 180 degrees minus theta, sine 180 degrees minus theta is equal to sine theta. Then here, it therefore means this is the same as RA sine RAB will be equal to AS times sine 180 minus that angle. It means sine that will be equal to RAB again. This will be equal to RB times sine RBA all over BT. You multiply by sine. Sine 180 minus something is equal to sine that thing. So sine RBA here. So conclusively, this and this are going to go out, this and this are going to go out. We go to the same conclusion RA over AS will be equal to RB over BT, and it has been proven. Then we are in now question 10.2, and in question 10.2 here, we are given that O is the center of the circle W, triangle PWS, which is PWS is drawn with P, W, and S on the circle. So with that, we can conclude that here it's 90 degrees. So in other words, we are saying angle PSW, that one is equal to 90 degrees. Why are we saying it's 90 degrees? It's an angle in a semicircle. It's an angle in a semicircle because PW is diameter and is subtending that angle at the circumference. Then you are also told that OR is perpendicular to PS. PRS is produced to T. SW and OT intersect at V. Then OV. So in other words, you are told OV, this part, OV is to OT. OV is to OT, it's 1 is to 4. OV is to OT, it's 1 is to 4. Okay, meaning to say if OV, this can be denoted by X, then 1X, then OT 4. So we can denote it as 4X. Then the first part is saying prove with reasons that OR is to WT is equal to 1 is to 2. But you have to take note of these ratios. This ratio is the same as saying OR over WS. OR over WS is equal to 1 over 2. So if we are to check in this particular case, because we have proven that this angle is 90 degrees and we are given that this angle is 90 degrees, we can therefore conclude that these two angles are corresponding and they are equal. Therefore, this line and this line are parallel. So we have to highlight that so we can conclude that OR is parallel to WS. The reason converse of corresponding angles. Since these two angles are corresponding, we therefore conclude that these two lines are parallel. Then from there, we know OP is radius. And we know that OW is radius. Meaning to say this and this are equal. Therefore, we can now conclude that the ratio, those two are equal, and using parallel lines, we can conclude that this angle at the center there, that is POR, is equal to the angle W there. Why? So in other words, we are saying POR is equal to the angle PWS. Those are corresponding angles because we have proven that we have parallel lines corresponding angles. We have our OR, which we agreed that it's parallel, which has been proven that is parallel. Oh, sorry. So we said OR is parallel to the WS. So it's now proven that this angle is equal to this angle and this angle is equal to this angle. And this angle, as we can see, it's common. Once we have proven two, okay, we can just put it that P is equal to angle P. It's common. Therefore, we can conclude that triangle POR is equal to, sorry, not equal, but rather similar. Triangle POR is similar to triangle PWS. Therefore, we can now say PO over PW is equal to PR over PS, which is equal to OR over WS. The reason is those similar triangles. Then from there, we can therefore go to the required ratio OR over WS, which is this ratio, is equal to which one? Do we know PO? PO, we know it is R. Do we know PW? PW, we know it is R plus R, which is 2R. So our OR over WS is equal to 1 over 2, which is given OR S2WS is equal to 1S2 2. That one, it has been proven. Now we are on question 10.2.2, where they are saying calculate the length of PT if ST is equal to 15 units. We go to ST here, which is from here to here. ST, you are told it's 15 units. So what are we going to do? We are given a ratio earlier on of OV. So we will go OV divided by OT. That will be equal to OV linked to RS divided by OT linked to RT. What are we going to apply? Prop theorem. Prop theorem, which sides are parallel? It has been proven earlier that OR is parallel to WS. It has been proven earlier. So OV S to OT, you are told that it's 1 S to 4. Remember, we agreed that we have to know that this ratio can be written as a fraction. It simply means OV over OT is equal to 1 over 4. That is that, which is equal to RS divided by RT. But RT, we are given it to be 15. No, sorry. RS is the one. Oh, RS, we don't know it. Then RT here is gonna be RS plus ST, which is 15. Then from here we have an equation cross multiply. So you end up having 1 multiplied by that, we get RS plus 15 is equal to 4 times RS. Then take RS to that side, so your 15 is equal to 4 RS minus RS. So 15 is equal to 3 RS, divide both sides by 3. Divide both sides by 3, so your RS is equal to 5. These are 5 units. But don't forget that RS is equal to RP. What is the reason for that? Line from center perpendicular to a chord. lying from center perpendicular to a chord. So we can conclude that this distance which you are required to calculate, which is PT, will be equal to PR plus RS plus ST. So the PT will be equal to PR, we found it to be the same as RS, which we said it's 5 units, plus RS, which is 5 units, plus ST, which is 15 units. So eventually, final answer of PT is 25 units. Now we are on question number 11, which will start with 11.1. But if we check in the diagram, A, B, G, and F lie on the larger circle, then we are also told a smaller circle is drawn to touch the larger circle internally at A. Then we are told EA is a common tangent to both circles. EBCF, that's EBCF, is a tangent to the smaller circle at C. Then we are also told that AC is produced to G. This is AC, which is produced to G. Then we are told that AF cuts the smaller circle at D. Then A, B, C, D, and GF are drawn. A, B, C, D, and GF are drawn. Then if EAG is equal to X, if EAG, meaning to say we are talking of this angle, we are saying if that angle is equal to X, determine with reasons 4 other angles that are equal to X. If we check here, we are having a tangent. We are told that AE is a tangent. It's a common tangent. So it's a tangent to smaller circle and also a tangent to a bigger circle. So it therefore means that if we are to concentrate on the smaller circle, here we are having a tangent. Here we are having a tangent AE, and AC is a chord. And you have to know that the angle in the alternate segment will be equal to. So we can therefore conclude that our angle EAG, we can therefore conclude that our angle EAG the angle EAG is equal to angle D1. We are concentrating with the smaller circle. So the angle between this tangent EA and this chord AC is equal to the angle subtended by that chord in the alternate segment, which is D1. So the reason there is gonna be tan chord theorem. Is tan chord theorem. Since we are told that EAG is equal to X, so we can therefore conclude that the D1 is equal to X. Then from there, we go to the bigger circle. If we check, we have a tangent and we have a chord, which is chord AG. So it means the chord AG must subtend an angle there, which is equal to that angle. So in other words, we said this angle is also equal to X. Then we are saying this angle, when we concentrate on the bigger circle, must also be equal to X. So in other words, we are saying the angle EAG, the angle EAG is equal to the angle AFG. The reason is tan chord theorem, but in this case, we are concentrating on the bigger circle. So this EAG will be equal to, if we check the chord AG is subtending that angle AFG. Therefore, we can conclude that the angle AFG is equal to X. Because EAG, you are told is equal to X. Then, if we are to check, we can conclude that AE is equal to EC. We can conclude that AE is equal to EC. Or let me write it as CE. AE is equal to CE. Here we are told AE is a chord, common chord to the circle. Then we are also told that EBCF is a chord. It's a tangent. We are told AE is a tangent. Then we are told EBCF again is a tangent to the smaller circle. So these are equal because they are tangents from same point. Tangents from same point. If you check, they are all from E, and you are told EA is a tangent, and this one you are told it's a tangent. So if those two are equal, we can now come in triangle A, E, C. So we can now go in triangle AEC, EC, and conclude that the angle EAG, EAG, of which that angle we see it to be EAC, is the same angle as EAC in that particular triangle. That angle we can now conclude that is equal to ECA, which is C1, which is ECA. The reason these are angles opposite equal sides. Angles opposite equal sides. These are angles opposite equal sides. So we can conclude that the angle C1 is equal to X. Alternatively on that, you'd realize, so we are now saying this angle, we have it. So we are now saying this angle is X. But alternatively, let me put that in red. Because we have identified that this angle is X, it was already obtained that D1 is X. We can just conclude this is a tangent, this is a tangent, this is a chord, and the angle in the alternate segment. So alternatively, one would just come and say D1 is equal to the angle C1. The reason being tan chord theorem. The reason being tan chord theorem. Therefore, C1 is equal to X, since D1 has already been established, that is X. or someone would have started by getting this angle, then go there. Still the same. There's no royal way to Euclidean geometry. Then we need a fourth angle. If you check here, we have straight lines. So it means this angle C1 is equal to angle C4. So we can conclude that C1 is equal to angle C4. What is the reason for that? These are vertically opposite angles. These are vertically opposite angles. So we are now on question 11.2. If you check 11.2, it's saying prove that AG times AD is equal to AC times AF. When we see these types of questions, we have to think in terms of either proportionality theorem or similarity theorem. Yes, it's like they are not written as a ratio, but we have to understand that ratios, we can play with the ratios so that we can write them as products or we can write the terms as quotients. So we are going to apply either of the two, proportionality theorem or similarity theorem. If we go to the triangles that we did here, the angles that we calculate, if you realize we calculated that D1 is x and we determined that this angle is x, so we can easily conclude that this line and this line, we can conclude that those two lines are parallel. So in other words, we are saying that's our first statement. So we are going to say, see, our D1 is equal to our AFG. It has been proven earlier both are equal to x. This has been proven already. So what can we conclude from there? We can therefore conclude that the line CD is parallel to the line GF. The reason is converse of corresponding angles. Converse of corresponding angles. So we now have those two lines which are parallel. And we have this triangle and this triangle. So as we can see, we can now simplify. We can apply proportionality theorem. So we can say AC divided by AG must be equal to AD. Here we said A, C over A, G must be equal to A, D divided by A, F. And the reason for that is proportionality theorem. Is proportionality theorem. Which sides are parallel? CD has been proven to be parallel to CD is parallel to GF. It has been proven earlier in this question. Then from here we can cross multiply AC multiplied by AF must be equal to AD multiplied by AG, which is what is required there. So we just need to rearrange. We are having AG multiplied by AD, which is equal to AC multiplied by AF. This has been proven. In this case, you are required to prove that triangle. Let me mark it using red. You are required to prove that triangle AGF. This is triangle A coming here, AGF. This one, you are required to prove that that triangle is similar to triangle ABC, which is this one. ABC. So, if we are to check in those two triangles already, we have an angle AFG. If you check, we have an angle AFG. That is question 11.3. We have an angle AFG, which is equal to angle AFG. It's first, second, first, third, second. So it's supposed to be first, third, second, which is angle ACB. If you check that angle ACB, it has been calculated already. Both are equal to x. Both are equal to x. It has been calculated long back. Then, if we are to check this angle here, if we are concentrating on the bigger circle, is equal to this angle. They are angles in the same segment, this one and this one. So in other words, we are saying angle F, it's angle FGA, it's angle FGA, which is equal to angle FGA. If we check it, last, second, first, last, second, first, it's equal to angle CBA. What is that? The reason those are angles in same segment. Then we can therefore conclude that the last set of angle GAF, the angle GAF will be equal to the angle GAF. We said second, first, third. So BAC equal to angle BAC. With similarity, it's very important to check on the order of the vertices. This reason for this one is the third angles of the triangles. of the triangles. Since you have proven that two corresponding angles are equal, it therefore means that third angles are also equal. Therefore, we can now conclude that triangle AGF is similar to triangle ABC. It's already proven. Right, we are doing the last part of the question, which is 11.4. We are doing part 11.4 now. So if you are to check on that question, we are there are things that are given. You are required to prove that this GF squared is equal to BCFC AF, that product, O over AD. Now, how are we going to do it? So, since we have proven part 3, we can use that ratio. Okay, let us write the ratio in full there. It means AG it's AG, not D. It's AG divided by 1, 2. So 1, 2 is divided by AB. Must be equal to what? We come here. Must be equal to AF divided by, here it's 1, 3. So here it's 1, 3. So it's divided by AC. Then which is equal to GF, which is 2, 3, 2, 3. So it's divided by BC. What is the reason for this? It's because triangle AGF is similar to triangle ABC. So from here, let us now compare the ratio that we have with the ratio which is in question. Okay, in question we have GF. Do we have GF here? Yes, we have GF. In our question, we are having BC. Do we have BC here? Yes, we have BC. In our question, we have FC. Do we have FC here? No. So this one, we got it. This one, we got it. FC, we did not get it. AF, we have AF there. We have AF there. Then FC, we said we do not have. AD, we don't have. So it means this one is out because there is no letter which is in this ratio which is there. So we are going to utilize this part of the ratio. So let us try to make that one which is not in our formula the subject of the matter. So it means we are now going to cross multiply. When we cross multiply, our AC is going to multiply the GF. Then our AF is gonna multiply the BC. Then we make AC the subject of the formula, one which we never had. AC divide here by AC, come divide here by AC. It's correct here. So we are left with, sorry, we want to make AC because AC is the one that we don't have. So we are going to divide both sides by GF. Divide here by GF. So we make AC subject of the matter. AC equal to AF. AC equal to AF times BC all over GF. We have this. Then we go, what is it from our question we are left with? We are left with CF and AD. When we go, that's where we have our AD. That's where we have our CF. But if we check from what we have already done, we never did anything that is relating CF. But we can now come here. Let's use the blue ink. Or let's just use the black. If we check this one, AD, which is the other part that we are left with here, we can check it's in which triangle. Let us check the triangle in which we are getting that AD. Here is the triangle where we are getting that AD. Then we go and check in which triangle are we getting CF. But if you check, we are getting it in this triangle and also in this triangle. But what normally guides us, we must link with the angles that with the work that we would have calculated earlier on. So if we are to check if we are to take this angle, there's not even a single angle that was calculated earlier. So we can decide to take this one. Why are we taking this one? Because we have angles that have been calculated earlier. In other words, this we found long back that it's X. So if we are to check, we can talk of this triangle and this triangle, but with issue of similarity, it is very important to consider the order. So it means we are going to choose the triangle. So we are now going to say, if you check triangle D1, that angle D1, we found it long back. That angle D1 was equal to angle C4. Both are equal to X. It has been proved earlier on. Then if you check, earlier on, we concluded that this line and this line are parallel. So we can conclude that this angle G here is equal to our angle C2, because we have 1, 2, 3, 4. So we can conclude that that angle C2 is equal to the angle G. Why? These are corresponding angles. These are corresponding angles. If you check earlier on, it has been proven here that CD is parallel to GF. So with this, we can conclude that the third angles, which is the angle A3, is equal to the angle F2. Here, because two angles have been proven, we can just conclude these are third angles of a triangle. But if you check in our, yes, we can just conclude that these are third angles. That is this angle and this angle. Those are third angles. But for those who might have done the longer way, they might have identified that this triangle was similar to this one, this angle was equal to this one, then they tried to equate these two angles using angles in the same segment. But in this case, we can just use the third angles of a triangle. Then from there, we can therefore conclude that triangle DCA, we can conclude that triangle DCA is similar to triangle. What is the triangle? Triangle DCA is similar to triangle CGF. And the reason is because we prove that the three corresponding angles are equal. So these two triangles are similar. And take note, when proving that is one way of proving that the corresponding angles are equal. Here, the reason why we said this is because we have proven that these three angles are equal. Then, once we can now derive a ratio from this, the same way we derived from here. So we can say DC, therefore, DC divided by DC 1, 2, 1, 2 divided by CG must be equal to DA divided by 1, 3, 1, 3. So it's going to be CF, which is equal to, here, CA, which is 2, 3, divided by 2, 3, 2, 3. We are coding them as 1, 2, 3, 1, 2, 3. So here we are saying 2, 3 divided by 2, 3, which is GF. What are we going to do from there? Go back to our ratio. We once said CF was left out. Let us check. We have CF there. We have CF here. That FC. Let's check another one which was left out. It was AD. It was AD. Let us come here. Here. This is that DA. Let us check. We have GF there. If we check here, we have GF here. Do we have DC? We don't have DC. Do we have CG? We don't have CG. Again, it implies that we are not going to be worried about that one. So we are going, here we are left with again CA, which we do not want. We are left with CA. So if we are to check, it therefore means we are going to cross multiply DA times that. So we are going to be left with DA times GF, that is equal to CA times CF. Can you please divide both sides by CF because we want to leave CA alone? Divide here by CF, divide here by CF. So here, so we are left with DA times GF all over CF must be equal to CA. If you check, we now have that which is equal to CA, that which is equal to CA. So we can now equate. So we can now say DA multiplied by GF Oh, based on, we can now use the actual naming which is being used in our equation. If we check, DA is AD multiplied by here GF, that one, all over CF, or they use it as FC, must be equal to what? That one is AF. Do we have AF there? Yes. BC, we have it like that, all over GF. We have it like that. Why are we saying these two are equal? Because both are equal to CA. Let's cross multiply, so it means our AD times our GF equal to AF times our BC times our FC. Then we divide both sides by AD. We divide both sides by AD. Therefore, it means that this and this will cancel out. We are left with GF times GF. It becomes GF squared being equal to, check here, we start with BC. We have our BC. We have our FC. We have our AF here, all over AD. This becomes our answer. It has been proven. Thank you.